Hey guys, welcome to Conceptual Geometry, Unit 4, Transformations Review. First question, what kind of symmetry does a rhombus have? So we've got point and line. Line symmetry, can you fold this in half? And if it's a rhombus, yes you can. There's horizontal and vertical line symmetry. Point symmetry, if you remember, is the shape the same if it's rotated upside down? And yes, it would be. The point would rotate down here, and the left point would rotate to the right point. So it does have both. And that would be choice 3. What is the image K, 2K, after reflection through the origin? So if you look at your summary sheet, reflecting through the origin means you negate both, negative x, negative y. So what you would have to do then is negate both of those, and that is choice, it would be negative k, negative 2k, so that's choice 3. Question 3, it says, which geometric figure has 72 degrees rotational symmetry? So you need to know the number of sides for each of these. A hexagon has 6 sides, pentagon, 5, a square has 4, and a rhombus has 4, but they're not all the angles are the same. So what you can do to determine the angle of rotational symmetry is you take 360 divided by the number of sides. So hexagon would have 60. It's clearly not that one. 360 divided by 5 is 72. So pentagon is the one that has 72 degrees rotational symmetry. A square would have 90, and a rhombus would have 180. In the accompanying diagram of a figure and its image, what type of transformation is illustrated? So what changed going from here to there? All right, well, if you notice, it's pointing the same way. It's not a reflection because I can't fold this over top of that because this point would go the opposite way. So clearly what happened is we just slid it across our paper. That is called a translation. A slide or a glide is a translation. Question 5. If a translation moves A, 1, 4, to A prime, 4, 6, what will be the coordinates of the image of B, negative 2, 3, under the same translation? So what we need to do here is we need to figure out what are we doing to the x coordinates, and then what are we doing to the y coordinates. So 1 went to 4, that means we added 3. 4 went to 6, that means we added 2. So what I need to do to this coordinate is apply the same rule. To the x, add 3. To the y, add 2. So negative 2 plus 3 is 1, 3 plus 2 is 5. The correct answer would be 1, 5, and that's choice 1. Question number 6, it says, what are the coordinates A, negative 3, 9, after a rotation of 90 degrees? So if you look at your summary sheet, the rule for rotating 90 is negative yx, which means I need to take these, switch them, and negate the first one. That would leave me with negative 9, negative 3. So negative 9, negative 3 is choice 1. Question 7, in the accompanying diagram, a figure and its image are shown. Which type of transformation is illustrated? So the one on the other page was a translation because we just slid it. But notice we didn't just slide this one. This point is now over here. So what we did is we rotated the image around. Okay, so if you spin your paper around this way, this shape would eventually line up on top of that one. So that is clearly a rotation. Question 8. State the coordinates of the point negative 2, 5 under a reflection in the line y equals 4. First thing we are going to do is plot the point negative 2, 5. Next, we have to graph this line y equals 4, but remember, that means crosses the y-axis at 4. So here's my y-axis, there's 4. Here's the line, y equals 4. So what will happen is this point just gets reflected over here. That was pretty easy. Coordinates now, negative 2, 3. You can write it on the grid. Or you could write it over on the side. Doesn't matter. Number 9, it says the three vertices of triangle ABC are located in quadrant 2. So let's make a quick sketch. Remember your quadrants. 1, 2, 3, and 4. So the three vertices of this triangle are located in quadrant 2. A, B, C. The image of triangle ABC after a reflection in the x-axis. So here's your x-axis. This will get reflected down here. Okay, so it looks something like this. A prime, that'd be C prime, that'd be B prime. The image of triangle A prime, B prime, C prime, so now I'm talking about this one, is then reflected in the y-axis. So now this one gets reflected in the y-axis and goes over here. Now, because this is not multiple choice, we kind of need to show work for it. So that would be C double prime, that'd be A double prime, that'd be B double prime. In which quadrant is A double prime, B double prime, C double prime located? Remember, this is quadrant 4. That's where we're located. So that would be the answer to the question. Question 10. If 2, negative 3 is transformed to 6, negative 9, state the transformation that took place. Find the image of negative 1, 4 under the same transformation. Now, if you notice, the numbers for our image are completely different. So it's not a reflection or a rotation. It's either a translation or a dilation. 2 goes to 6, negative 3 goes to 9. Notice in both of those cases, you multiply by 3. So this is a dilation of scale factor 3. That's the first part of our answer. D for dilation, scale factor 3. So now what we need to do is we need to find the image of this point under the same transformation. So all we need to do is multiply both of these by 3. Okay, so my new image will be negative 1 times 3 is negative 3. 4 times 3 is 12. And there's that answer. The vertices of triangle HOT are H is negative 2, 1. O is 0, 0. And T is 1, 4. Draw triangle HOT. So that's what I will do first down here. All right, so H is negative 2, 1. Be right here. O is 0, 0. And T is 1, 4. Okay, so let me connect those sides. All right, so now what do we have to do to that? It says graph and state the coordinates of triangle HOT prime, the image of triangle HOT under the translation to negative 3. So there's a couple ways we can do this. That translation means right 2, and because that's a negative 3, that means down 3. So I could graphically do this right now, going right 2, down 3 for every coordinate. And that's usually what I like to do. I'm more of a visual person, so I will do that. It doesn't matter what you start with. I'll start with T. I'll go right 2, down 3. So T prime is here. Then I'll take O, go right 2, down 3. There's O prime. And H, I'll go right 2, down 3. And there's H prime. Then we'll connect those vertices. So we still need to write the coordinates down. So back up here, I need to state the coordinates of H prime, O prime, and T prime. Now, if you're more of a visual person, what you would do is you would come down here and you would look at these coordinates and say, oh, here's the coordinates of H. It looks like it's 0, negative 2. O is 2, negative 3. And go back up and write that. And T is 3, 1. I want to also show you guys, if you're more of an algebra person, how you could get these coordinates without the graph. You would take this 2 and you would add it to every x value of our original points. Okay, so if I do that, negative 2 plus 2 is 0. 0 plus 2 is 2. And 1 plus 2 is 3. Then you would take this negative 3 and you'd add it to all the y coordinates of our original points. So 1 plus a negative 3 is negative 2. 0 minus 3 is negative 3. And 4 minus 3 is 1. And you notice these coordinates match what we came up with down here. Okay? Next step. It says graph and state the coordinates of HOT double prime, the image of triangle hot prime. So that's important. We're starting with the triangle we just got, which is the red one. Now we're doing a translation of 3, 5. So translation of 3, 5 means right 3, and since that's positive, up 5. All right, so for this one, I'll just do the coordinates first to show you it doesn't really matter what order you do this, as long as you end up with the picture and the coordinates. So if I want to get the coordinates first, I need to add 3 to these x values. Remember, this is the triangle we're moving. All right, so I'll add 3 to all of those. 0 plus 3 is 3. 2 plus 3 is 5. 3 plus 3 is 6. Then I need to add 5 to all the y coordinates. Add 5 there, there, and there. So negative 2 plus 5 is 3. Negative 3 plus 5 is 2. 1 plus 5 is 6. Now you would plot these coordinates on the grid down below. All right, if you're a visual person, you're taking this red triangle, you're going right 3, up 5. So you're starting here, right 3, up 5. And then that would be t prime, double prime, sorry. Okay, so right 3, up 5, there's t double prime. Do the same thing with O, right 3, up 5, O double prime, and then H, right 3, up 5, H double prime. Connect those sides. Now when you're done, you should have 3 triangles that are exactly the same size and shape, because all we did is we started here with the blue one, translated it to the red one, then took this red one and translated it to the green one. Now the follow-up question always wants to know, how can you do this in one step? How can you go from here to here? And you can just pick 2 coordinates. You don't have to do the whole triangle, but t to t double prime. What did we do? We went right and we went up. So it looks like we went right 1, 2, 3, 4, 5, right 5, up 2. So both of those are positive. So that will give us a translation of 5, 2. That is my answer. Now, we can also do that algebraically. We could take these 2 translations and just add them together. Watch how it works. Translation of 2 comma negative 3 plus a translation of 3, 5. If I add 2 plus 3, I get 5. So that's your first number. Negative 3 plus 5 is positive 2. There's your second. So that's another way you could do that visually, or you can apply the rule. All right, last number, last page. The graph of figure ABC is shown below. All right, it's already done for us. That's great. I don't need to sketch that. Coordinates are given to us. What are we going to do first? It says graph and state the coordinates of figure A prime, B prime, C prime, the image of ABC after a dilation of scale factor 1/2. So because that's less than 1, that means it's going to get smaller. Now, I don't do this visually. I always apply the rule here. So I will write my coordinates down, A prime, B prime, C prime. Remember, what we do for a dilation is we multiply. So I need to multiply all of these coordinates by 1/2, which is the same thing as dividing by 2. All right, you can put a 0.5 in your calculator and multiply them out. You can divide by 2. I don't care how you do it, but we're going to get these coordinates. Negative 6, 2 becomes negative 3, 1. Negative 4, 4 becomes negative 2, 2. And 2, 2 becomes 1, 1. So now what I need to do is I need to plot those on the grid below. Okay, so A prime is negative 3, 1, right there. B prime is negative 2, 2, right there. And C prime is 1, 1, right there. Let's connect those. So remember, what a dilation does, it enlarges or reduces the object. So this is half the size of the original, which makes total sense. Okay. Part B, graph and state the coordinates of A double prime, B double prime, C double prime, which is the image of A prime, B prime, C prime. So I'm taking the new one, the one we just shrunk, after reflection in the origin. So reflecting in the origin, if you look at your study guide, the rule is negative x, negative y. You negate. Now, you can do this visually, but I like to apply the rule here because I've got the coordinates listed up above, and it's such an easy rule to apply. I think this is faster for me anyway. So all we're going to do is negate both coordinates. Okay, so a double prime becomes 3, -1. B double prime becomes 2, -2. And C double prime becomes -1, -1. Now we just need to plot those points. So A double prime is 3, -1 right there. B double prime is 2, -2 right there. And C double prime is -1, -1 right there. Connect A to B, B to C. Make sure you connect those in the proper order. So this is a reflection of this through the origin. Visually, that should kind of make sense. Look how they line up. Kind of cool. All right, the last one. What does it say? Oh boy, graph and state the coordinates of A triple prime, B triple prime, C triple prime, which is the image of figure A double prime, B double prime, C double prime under reflection in the line x equals 3. So x equals 3, remember, crosses the x-axis at 3. So let's go here. Crosses the x-axis at 3. It's a vertical line. Looks like this. There's your line x equals 3. There is no rule for this. We have to be visual. So if you notice, A double prime goes to A triple prime, but it stays right there. B double prime goes one space to the line, then one space to the other side. Goes right here, B triple prime. And then C would go 1, 2, 3, 4. 1, 2, 3, 4 would go right there. C triple prime. Connect A to B to C. Now we have to state those coordinates. Like I said, there was no rule. So this one we had to sketch first and then come back up here and we have to get the coordinates from our graph. All right, so A triple prime didn't move. It's the same as A double prime, so that's 3, -1. B triple prime looks like it's 4, -2. And C triple prime is 7, -1. So we've got all the coordinates, which is super important. You have to write all the coordinates down. Remember that in your exam. And we have everything labeled on our graph. All right, guys, so that concludes the Unit 4 review. As usual, if you have any questions, don't hesitate to reach out. Thanks a lot for watching, and we'll see you in class soon.